My PhD work is on membrane distillation, which is the machine, which is, you can see it right now. It uses the seawater for desalination to produce high purified water. I can use the solar energy for the water desalination. We wanted to use this as a solution for the problem of the water shortage for the UAE and for the growth and development of Abu Dhabi.
I'm carrying out research in desalination, particularly in the technique of forward osmosis. And this is the experimental setup that we are using in our lab to test forward osmosis. Forward osmosis is an emerging technology that is still in its maturing stages. And in forward osmosis, what we are trying to do is we're trying to separate water from salt using the osmotic pressure difference between our feed and our draw solution as a driving force. So here we have feed as our seawater, which is at a lower concentration than a draw solution. Our draw solution has a higher osmotic potential, therefore the water will move through a membrane and it flux naturally down through an osmotic pressure gradient, and it will dilute our draw solution, from which we can then extract our purified water. In our lab, we are carrying out this process under different parametric conditions and operating conditions, and we are testing the flux and seeing how the flux increases or decreases with different draw solutions with different flow rates which are being pumped. Forward osmosis is compared to RO is considered low energy because we are not using pressure to drive water across a membrane. In fact, we are just using the natural osmotic pressure difference between the solutions to establish a gradient and a driving force. So it's natural and we do not need pressure. And right now we are in the testing phases and testing membranes and different operating conditions to see if we can optimize the process.